So SQS, it stands for a simple queue service. Simple queue service. And coming to the SQS, simply we can say, so here you can see it is a, the name itself says it's a queue. So that means like where we are managing all the messages in the queue. So usually SQS, it is a, simply we can say it's a queue where we can decouple the application, and not only decoupling the application, so we are going to manage all the messages in the queue only. So what is this decouple application is? To understand what exactly the decouple application, let me take a simple example. So usually what happens is in the organization, so let's say for example, let me take two tiers. One is the web tier, so which is nothing but a web server, or you can take it as a web tier. And I'm going to take it as one more tier called application tier. There is application server. So tier is nothing but layer. Okay, so it's like a client layer. Second one is an application layer. And here left side, I'm taking the clients. So usually the clients, what they will do, so they will request, they will make all the calls. Okay, so to the web server, simply we can see the web tier. Now the web tier, it is having some information. So when the client is doing activities, let's say the client is purchasing a product. The client is purchasing a product. Now the complete product information, that is the client name, a product name, and product ID, and the timestamp. So which product he is purchasing and how much amount he paid. So everything, it is available in the web server. So the information is available in the web server. Now this web server, what it will do? So it will directly send a message to the application server. That means, so we are doing a direct integration. So directly we are integrating our web tier with the application server. So whenever if you're doing a direct integration with the application tier, so usually what happens is, so we will be facing some lot of problems when we are doing a direct integration. So what kind of problems is, let's say for example, the application tier is down, then the web tier definitely it will be fails. Okay, it will fail all the messages to send the application tier. And let's say, so there is some heavy load on the application tier, then application tier, it cannot scale quickly. So that is one more issue. And third problem is, so whenever if you want to decouple between two services, so definitely there will be it will reduces the flexibility. So as it is reducing the flexibility again, so this will cause a problem in the organization. And one more thing, so we will have a risk of message loss. Let's say when you are sending the message from a web tier to application directly without using a barrier or SQS. So definitely, the message, sometimes the information will be lost, or sometimes there will be a delay response. Like these are all the problems each and every day we will be facing. And when you are integrating SQS with the application tier, so now how the setup works is, now let me take the same setup. Again, web tier, that is a web server. Now I'm taking the application tier, app tier. This is a web server. And here clients. So the clients are making some request in the application. Now the web server, it is receiving all the client requests. Now the web server, it is having some information. It is having some information, a data, or it could be anything. So now here you can see, so here we are going to use a barrier called, simply we can say SQS. This is the SQS. So instead of directly integrating web tier with application server, so we are using a bridge, or simply we can say a barrier called SQS queue. Let's say this is the SQS queue. So now when you do this kind of setup, when you're decoupling applications with the SQS, the web tier, what it will do, it will send a message to the SQS queue. And after sending the message to the SQS queue, the SQS queue, so instead of sending directly, message directly to the application tier itself, it will calls the message from the SQS queue. So we are putting all the messages in the queue, and now the application tag, it will calls all the messages from the queue. And when you're doing this kind of setup, so here you can see the message is successfully stored, successfully stored, that is safely stored in the SQS queue. The application tag, it is reading messages from the queue, and it will process all the messages asynchronously. Asynchronously. And when it is processing all the messages to the messages asynchronously, so each and every the consumer, or simply we can say the receiver, so they will be receiving messages from the queue. Okay. And after successful processing, so then again the message will be deleted from the queue. Okay. So these are all some of the benefits. So where when we are using, or when we are decoupling SQS queues with the application. So most of the times, so we are going to use SQS for decoupling the application. This is one benefit. And second benefit is, whenever if you want to achieve scalability, so that is when you want AppTire to process the message at its own pace, so you can also use SQS queues for decoupling. And when you want reliability, so before it is reducing the reliability and flexibility, right? Now when you want reliability, so you can also achieve that by using SQS queues. And coming to the failure also, let's say if any message is getting failed, so when the message is processing from the SQS queue, if it is getting failed, then that message will be automatically added to the one more queue called DL queue. So that is a dead letter queue. So the dead letter queue, it will contain all the failed messages. Then it will also retry all the failed messages once again from the DL queue. And again, it will send all the messages to the, simply we can say, the consumer. Okay. So this is how, the SQS queues, it works in the application. So now what I'll do, first of all, let me tell you what exactly SQS, and what are the components we have in the SQS, and what are the different types of queues we have in the SQS, and how the SQS service works, everything that we will discuss. Okay. So now coming to the SQS service, as I told, SQS, it is used to decouple application, and we are going to manage all the messages in the queue. And remember, the SQS queues, it will use a pull-based system, a pull-based messaging system. So that's the reason. So there will be a guarantee, a delivery of message at least once to the consumer. So in the SNS, there is no guarantee that the receiver or a consumer will receive a message. But here, we will have a guaranteed delivery of the message. And one more point here. So here, the receiver, he should communicate with the queue system. Then only, he can pull the message for the further processing. Let's say if the receiver is not communicating, let's say, for example, usually for each and every message, we are going to apply some visibility timeout. So within the visibility timeout, that is the default visibility timeout is 5 minutes. So within the visibility timeout, if the message is not pulled from the queue, then that message will be added to the, once again, DL queue. There's a dead letter queue, and the message will be processed once again to the receiver. Okay. So this is how we are going to, assign, we will apply a visibility timeout on the each and every queue in the assets. And once the message is processed from the queue, so here the receiver, he will receive the message within the next 5 minutes. So once the acknowledgement is taken from the receiver, then that message will be successfully deleted from the queue also. Okay. And basically in the SQS, we have two different types of queues. So one is, we are going to use a standard queue, and we are going to use one more queue called, that is a FIFO queue. So now what is this standard queue and what is this FIFO queue is? So FIFO is nothing but it is like, first in, first out. So first we'll talk about the standard queues, and then we'll talk about FIFO. So in the standard queue, so let's say, for example, we have some number of messages like message 1, and message 2, message 3, message 4, message 5, and message 6. So 7th message or 8th message, something like. So in the standard queue, so like usually what happens is, so, in the standard queue, remember one thing. So here we will have a best effort ordering. And one more thing. So whenever if you're using a standard queue, so in a second, we can send some, we can do unlimited transactions in the standard queues. And most of the times we are going to use a standard queues in the SNS only. And one more thing, when you're using a standard queue, so here we will have at least once delivery, at least once delivery. And sometimes, so the same message, occasionally that will be delivered to the end user, that is, a recipient or receiver. So sometimes, occasionally. So that's the reason. So if at all, if you want to go with the standard queues, you can go with the standard. But when it comes to the FIFO queue, the FIFO is nothing but first in, first out. First in, first out delivery. So what is this first in, first out delivery is? So there will be messages like which is having a preserved order. So 1, 2, 3, 4, 5, 6, 7, 8, something 9, something like that. And here, as it is first in, first out. So first, the message 1 will be delivered to the end user. So once it is processed from the queue successfully, then only the message 2 will be delivered. Then the message 3 will be processed. Again, the message 4 will be processed. Again, the message 5 will be processed. Like that, we are going to use a FIFO queues where each and every messages will be delivered in a order, in a specific order. And in the FIFO queue, so, in a particular second, we can do a maximum of 300 transactions only. That means we can send 300 messages in the, first in, first out queue. That is in the FIFO queue. This is about a FIFO queue. And here, so we will have a guaranteed delivery of message at least once to the end user. That is, the recipient or receiver, or simply we can say the consumer. So I think we discussed the SNS. It works based on pub sub model. Pub sub model, where the publisher, he will send messages to the topic, and the subscriber, he will push the messages from the topic. But when it comes to the SQS service, SQS, it is, in the SQS, we are going to use pro and as well as, cons model. What is this pro is? The pro is nothing but producer. It is the producer. And cons is nothing but it's a consumer. So the producer, what he will do, he is going to create a message, and he will send the messages to the, SQS queue. And from the SQS, the consumer, he is going to poll for the message. So simply we can say he will pull message from the queue. So that is nothing but the consumer. The consumer is nothing but simply we can say he is a receiver, okay, or the recipient. So that is nothing but the consumer. So here you can take a web tier as a producer, because from the web tier only the message will be delivered to the queue. So, and the application tier, you can take it as a consumer, because, the application tier only, it is going to pull the message from the queue, and it will deliver all the message to the end users, like, something like, it could be anything, like end user or endpoint, it could be anything. And in the SQS, so we have some different types of queues. So we have some different components. And what are the components we have in the SQS is, we have one component called queue. So the queue is nothing but it's like a container, or simply we can say it's a storage. So whenever if you want to store all the messages, so we are going to use a temporary storage. So that is nothing but the queue. So why it is a temporary storage? Because, so once the message is successfully pulled from the queue, then the message, it won't be available in the queue. That will be successfully deleted. So that's the reason it's a storage, a temporary storage. And we have one more component called a message. The message is nothing but, we know it's like the data, or it's like, it's a kind of information. And we have a producer. The producer is nothing but is a sender. So, like simply we can say the web tag, so where we are sending the messages. And you can take consumer. The consumer is like, he's a receiver. So where he is receiving all the messages from the queue, that is from the SQS queue. And we are going to have one more component called a visibility timeout. So what is the visibility timeout is? For each and every message, so we are going to apply the visibility timeout. So based on the visibility timeout only, so the message will be available in the queue. So once the visibility timeout is, if it is over, then if the message is not delivered, if it is not processed within the visibility timeout, then that will be added to the one more queue called DLQ. And what is the DLQ component is? It's a dead letter queue. And in the dead letter queue, so whenever if the message is not processed or if the message is getting failed, all the failed messages will be stored in the a DLQ only. There's a dead letter queue on. Not only DLQ, so here we will have one more a type of queue called delay queue also. Delay queue. So what is this delay queue is? So we will have a delay timeout also, that is a message delay timeout based on the based on the message delay timeout. So here, so if the message is getting delayed, then again that will be added to the one more a queue called a message delay queue. There is nothing but the delay queue here. So now what I'll do, first of all, let me write down the points for, SQS service, whatever we discussed as of now. That is how SQS works, and what are the components we have in the SQS, and what exactly SQS. And we'll also talk about some use cases. Once it is done, so we'll see the hands-on activities. So as a producer, how we are going to send messages to the queue, and as a consumer, how we are going to process messages from the queue, and how we have to apply visibility timeout on the queue, and what is a DLQ, everything we will discuss. Most of the times, we will be using, a SQS for processing the messages asynchronously. And if at all, if you want to decouple the microservices, we will be using a SQS only. And if you want best ordering processing systems, so we will be using SQS. So for buffering, load spikes, and for SMS kind of notification systems. And whenever if you want a retry mechanism in the messaging system for all the failed operations, again we will be using SQS service only. Now, when it comes to the SQS, that is, Amazon, a simple queue service. Simply we can say, so SQS, it is a queue to decouple the application or applications, and we are going to manage all the messages in the queue. And one more point here. So SQS, it will use a pull-based messaging system. SQS, it will use a pull-based system. So where we will get a guaranteed delivery of message at least once. Delivery of message. And coming to the one more point. So as I told, SQS offers two different types of message queues. So one is we have standard queue. And we have one more queue called that is, FIFO queue. And what is this standard queue is? The standard queue, it is used for simply we can say, or else we'll talk about the types later, what exactly the standard and as well as, FIFO queue. So let me write down one more point. So usually in the SQS, all the messages, so we are going to process by using FIFO only. So all the messages will be processed in FIFO queues only. That is, simply we can say a first in, a first out delivery. So there is no delivery. So for additional, if you want to understand, you can just write down the delivery also, or else first in, first out. So that is nothing but, a FIFO. And one more point here. So by default, a visibility a timeout of 5 minutes will be applied on each message, applied on the message. So once it is allocated to the receiver. So let's say within the next 5 minutes, if the receiver is not getting the message, or if he is not receiving the message, or else once the receiver is, let me write down one more point here. Once the message is processed successfully, and if it is acknowledged by user, in next 5 minutes, then the message will be deleted from the queue. Deleted from the queue. Let's say if the receiver is not receiving the message, then that message will be added to the dead letter queue for further processing. If receiver is not receiving message, then the message will be sent to a DL queue. So which is nothing but dead letter queue, okay, for a further processing. Again, the SQS service, it will process the message once again. But remember, definitely there will be a guaranteed delivery of message at least once. So that is nothing but simply we can say the SQS service. And coming to the some of the components. So first we'll talk about components, then we'll see how it works. So we have majorly, 4 components in the SQS. So one component is queue, and the second component is nothing but it's a message. The third one is producer, and the consumer, and we have a visibility timeout, and finally dead letter queue. So that is a DL queue. These are all the components we have in the SQS. So the queue is nothing but, as I told, it's a temporary storage. And when it comes to the message is nothing but it's a data or information. So the producer is nothing but the message who sends a message, who send a message. It's a component who sends a messages to the queue. So in the real time, who will send the message to the queue? So that is a web server, it will send messages to the queue. So then the web server, it will be the producer. So next, coming to the consumer is nothing but who receive a message, or who receives messages from the queue. So that is nothing but the consumer. So if you want, you can just keep application tire in the parenthesis braces so that it will be easy to relate. Coming to the visibility timeout, the visibility timeout is nothing but it's like this is the amount of time, a time. So that is applied for a message where it will be invisible once consumer receives it. Consumer receives the message. So that is nothing but the visibility time. And finally, the DL queue, there's a dead letter queue is nothing but, so it's like it's a kind of storage only, but where it will keep all the failed messages or unprocessed messages. It could be anything. So that is nothing but the DL queue. So these are all the components like we have in the SQS service. And if you see how SQS service it works is, so usually, we can take total 4 separate phases here. So the phase 1 is, so that it is like, a production phase. So that is a message, a production. And the second phase is, simply we can say the storage phase. And the third phase is, it's a retrieval phase. There's a message retrieval phase. And the fourth one is message a deletion phase. What is this production phase is? The message production. So in the message production, usually a producer, so he will send a message to the queue. So that is nothing but simply we can say a production phase. And once the producer is after sending messages by the producer, then that message will be stored in the storage area. So SQS it will stores messages in the queue. So this is nothing but simply we can say the message or storage section. And the retrieval is nothing but now the message is available in the queue. So in the retrieval, so usually the consumer what he will do, he is going to pull the message from the queue. So simply we can say the consumer will retrieve messages from the queue. So that is nothing but the retrieval section. And the last one, deletion is once the message is successfully processed from the queue, then the message will be deleted from the queue. So this is how, the SQS service, it works. Okay. And coming to the, standard queue and as well as a FIFO queue. So standard queue, it is always used for, simply we can say, for unlimited transaction. You can send some unlimited messages, in a second. And one more thing, so here we will have at least once a delivery. And sometimes the same message will be delivered occasionally to the receiver. So that is the issue here. And in the FIFO queue, so it is not like that. Here, first of all, the ordering is preserved. For each and every message, the ordering is preserved in the FIFO. And in the FIFO queue, so maximum we can send 300 messages in a second. And one more thing, so here we will have exact processing. So definitely the message will be processed to the end user. So there is nothing but the FIFO queue. Okay. So now what I'll do, so let me take the hands-on activities. First we'll see how we are going to create the queue. And after that, so using this SQS service, so we will also create one simple, event-driven application also by using the Lambda function. So as of now, we don't know what exactly Lambda. But remember, if you want to poll for the messages from the queue, so we need Lambda function. So usually, without Lambda, we cannot understand SQS, but don't worry. So anyway, we will create only the Lambda function, and in the Lambda function, so I'm just putting some simple Python code where it will calls all the messages from the queue and it will process all the messages to the destination called something like a DynamoDB. So now the setup here, what I'll do for simple driven application. Let me draw a simple architecture so that you can understand. I'll tell you the step-by-step process. Don't worry. Okay. So this is a SQS simple event driven app. So here, first of all, what I'll do, I'm going to take, two tiers. That is, one is a web tier, second one is application tier. So let me take two instances here. So one is, let's say this is a web tier. The second one is, let's say, for example, application tier. And or else, I'm going to take two different applications. Applications, or you can take, microservices, or you can take distributed systems. It could be anything. Let's say, for example, okay. This is one application and this is one more application. So directly we are not going to integrate SQS with from one to another, right? So if you do direct integration in a web tier with application tier, so definitely we'll be facing some lot of problems. So that's the reason. So here I'm taking SQS. Let me take SQS. This is a SQS. So this is like a bridge or a barrier between two microservices. So where it will send all the information to the SQS. Now again, the application tier, that is application 2, it will receive all the messages from the queue. So this I'm taking as a application 1, application A, and this I'm taking it as a application 2, application 2. So now when it comes to the simple event driven application, so here what I'm doing is, so first of all, I'm going to create one SQS queue, or else let me take the destination called DynamoDB table itself. DynamoDB a table, or just go for DynamoDB database. Let's say this is our DynamoDB database. This is the destination. And here I'm going to use one more service called a Lambda. Just take Lambda also. This is a Lambda. Okay. So if you see, now I'm taking some clients, the clients like users. Let's say these are all the users. So first of all, the users are interacting with the application A. Now, so this the application A, so it is sending all the information to the SQS queue. Okay. So now the Lambda, what it is doing is, so in the Lambda, so whenever the information is stored in the SQS queue, so that information will be processed to the application 2. And finally, the application 2, it will process, or it will send the information to the destination called Lambda. Sorry, Lambda, not, it's a DynamoDB database. Okay, so let's say this is a setup. So here I'm taking a simple example, like let me take a e-commerce application itself. So usually the user, what he will do, he will purchase the product. Now the product information, complete information will be sent to the Amazon SQS queue. The complete information is stored in the queue now. From the queue, so if you want to receive messages, if you want to receive the information to the next microservice called application 2, then the application 2, what it will do, it will poll for the message. Then when it is polling for the message, so there should be someone who should who should do all this automation, right? So the automation we are taking with the Lambda. So here the event trigger is Lambda here. The Lambda, what it is doing, so when the information is sent to the SQS, that will be processed from the queue and it will send to the application 2. And from the application 2, so the information directly it will be sent to the database called DynamoDB database here. Okay. So this is the requirement. Now for this, so first of all, go to the console management, navigate to the DynamoDB, create one DynamoDB queue here. Sorry, DynamoDB database. Then we'll create SQS queue later. Click on create a DynamoDB table. And when it comes to the table name and as well as the partition key and sort key, so for that, I'm just keeping all the information in my repository itself. You can check out my repository, and I'll also share my repository code with you. So just go to my GitHub, and in the GitHub, you can find one repository called, so that is a simple event-driven application. Open the repository here, and here I have, I just created complete, the step-by-step processor here. And in the DynamoDB table, when you're creating the table, just specify, the table a name called product widgets, because so everything I already hard coded in the Lambda function, that is in the Python, using a Python code. So that's the reason. So if you want to take a different Lambda function, you can go with a different name, or if you want to go with the same my Lambda function itself, the same code itself, then you can just hard code the values here. Copy the product visits as a table name, and go to your DynamoDB table. Just paste the table here, table name here. And partition key, I specified, something like a product visit, a visit key. Again, copy the partition key and paste it here. And that's it. The sort key is optional, and the remaining all the table settings, I'll just keep it, default settings, and click on create DynamoDB table first. Now the DynamoDB table is successfully created. Here you can see. So the table name is product visit, and the partition key is nothing but product visit key. So just give refresh here. Now open your table. Now when I open the table, when I click on explore table items, so just scan for the items and just click on run here. Now here you can see there is no item in the table. Now through the SQS, so by executing my Lambda function, I want to keep the complete SQS information into the DynamoDB, the queue information into the DynamoDB table. So this is my concept. Then what I'll do after creating the DynamoDB table, so now I'm going to create a SQS queue here. So you can go for standard queue itself. If at all, if you want to go with the FIFO queue, also you can go with the FIFO queue. Again, come back to the console, just navigate to the SQS and open SQS service once again in a new tab. Click on create a queue. So just go with the type of the queue called, standard queue. So where we will have at least once delivery. And here you can see this is for best, best effort ordering. And here the message ordering is not preserved. So each and every message will be delivered to the consumer. But here in the FIFO, the message ordering is preserved. And definitely, so there will be exact, once processing will be there in the FIFO type of queues. So just specify the standard queue name called something like product visit data queue here. You can go with any name, but I just hard coded, all the names in the Python code. That's the reason. Just go with the same names. And in the configuration, you can see the visibility timeout. So for message, I'm applying the visibility timeout called 30 seconds. And the message, you can also specify the message retention period also. So maximum, in the queue, we can keep almost 14 days. So each and every message. And you can also go for a delivery delay also. So that is a delay queue. So if you want to apply a delay time for each and every message, you can just go for a maximum 15 minutes. So you can start with the 0 seconds. And one more thing, remember, using the SQS, the maximum message size, it should be a 256 KB only, not more than that. And finally, so encryption, you can use any encryption, that is a data trust encryption or a server-side encryption also. And if you want, you can enable the encryption or else you can disable the encryption. But let me go with the default settings. Scroll down here, everything just go with the default. And finally, the dead letter queue, it is not enabled. So usually we are using the dead letter queue so to keep all undelivered messages or all the failed messages. That is nothing but the dead letter queue. First, click on create queue here. So once the queue is successfully created, now here you can say this is a SQS queue. So if at all, if you want to copy the queue URL, simply we can say, the queue name, you can copy the queue URL and you can paste it somewhere. So in the paint or in the text editor, and come back to the queue. Once the queue is done, next what we will do, so we are going to create a Lambda function. So go to the Lambda. So usually what exactly the Lambda is, the Lambda, it's completely a serverless service. where we can run our code without thinking about the servers. So if at all, if you want to create one function in the Lambda, let me open the Lambda again, one more in new tab. So navigate to the Lambda. So usually the Lambda, it will support, multiple programming languages. So you can use any runtime here, Java or, Python or Ruby or .NET, or it could be anything, or PHP or any other runtime also. So, but don't worry, we'll talk more about Lambda in the next upcoming classes. Anyway, we will have a separate session for Lambda. But just keep only one point in the mind. So Lambda, it is completely a serverless service where we can run our code without thinking about the servers. The complete underlining, platform will be managed by the provider itself. It's completely comes under, the fast service. There is a function as a service where we are going to create function for performing, specific operations in the application. Just create a function here, and the function name. So the function name also, here hard coded. So just specify the function name, something like, simple app function or simple event driven app function. You can go with any name. So just specify the name here. And coming to runtime, just go with Python latest version. That is a Python 3.13, or you can go with Python, a 3.12 or 11. You can go with any previous versions also. And while creating Lambda function, basically the Lambda, it will use a basic Lambda execution, role. So in the role, there will be only a basic Lambda execution permissions. Now, whenever if you want to create a new role, so by using the policy templates, existing policy templates, you can also create one new role in the Lambda function. Just specify the role name here. The role name, something like, simple app role. You can just go with the same name. And the policy templates. So here for microservices, I'm going to use one policy called a simple microservice permissions for DynamoDB. And for SQS, I'm going to use one more policy called Amazon SQS polar permissions. Just select the second policy in the role. Now, a new role will be created for the Lambda function. And in that role, so these two policies will be added into the role also. So finally, click on create Lambda function. This is the step number 3. Remember, the step number 1 is first we have to create the destination called DynamoDB table, and next we are going to create SQS queue, and third we are going to create Lambda function. And fourth step is, so we will keep some code in the Lambda function, and after that, so we are going to send messages to the SQS queue. When the message is stored in the SQS queue, then the Lambda will be executes, and that message will be finally stored in the DynamoDB table. Now we'll see. So the Lambda function is successfully created. So once it is created, so in the Lambda, by default, we will have a just a second. Till it is loading. And in the Lambda, so here we will have a default code. So you can also remove that code and just come back to the repository. And here you can see I'm giving one more a file called that is a Python code, that is a complete py file, function.py file. So open the simple app function file here. There's a Python code. Copy this entire code. Copy the code and come back to the Lambda function. And here, so I have some default code in the Lambda function. Just remove each and everything. Now just paste the entire code. Paste your code here. And in the code, so what I'm specifying is, so a region, you can take any region. If you want to change the region, you can change the region also. So now we are in the Mumbai region, right? Just update your region code here. AP-South-1. You can change the region like, however you want. So wherever you are doing, just specify the region name here. So AP-South-1. That's it. And no need to change. So each and everything is already pre-configured and it's completely hard-coded. And you can see here, so when the user is, sending some information like a product ID and product name and category and, price unit and this kind of information, then the Lambda, what it will do, it will store all the information into the DynamoDB table by keeping each and every item in the table that is in the rows. And this is a simple Python code where it will always monitor SQS queue, and that will be sent to the directly to the DynamoDB table. That the complete queue information will be sent to the DynamoDB table, and the table partition key is nothing but simply we can say table name is nothing but product visits. And here I didn't specify the partition key. Anyway, it will take partition key by default. And that's it. Once the Lambda code is pasted in the once the Python code is pasted in the Lambda function, so just click on deploy here. So deploy is nothing but simply we can say saving the code in the Lambda function. So now the code is successfully saved. Okay, so this is a step number 4. So here you can see once again you can come back to the readme file. So first we created DynamoDB table, and next we created SQS queue. Third, we created Lambda function, and we specify, you can go with any runtime here, 3.9 or a 3.12, or it could be anything. Then we created one new role for policy for templates by specifying the role name called simple app role. There I selected a policy template called simple microservice permissions for DynamoDB and SQS polar permissions also. And finally, so I pasted complete, the Python code in the simple app.function.py file. So if you're clear up to now, then we'll see how we are going to configure Lambda in the SQS. Then later, we will send some information to the SQS queue, and that information will be triggered by Lambda, and that will be stored into the destination called, the DynamoDB table. So clear up to step number, 3. If you're clear, we'll go for step number 4. Yeah, online, clear up to now. Sai Kiran, okay. And what about others? Vinay and Rajita, Selvan, Amruta, Chandini. Okay, then. The next step is, so go to the SQS queue here, and in the SQS, now whenever if you want to trigger the SQS queue, we are going to use on Lambda function. So already the Lambda function is created, right? Now come back to the SQS queue here, click on the Lambda trigger, and yeah. So click, I think select your Lambda trigger. So let me delete this. This is the existing trigger. This is not added. Let me delete this. Now just click on configure one more Lambda function, and just select your Lambda function here. So we have just now we created one Lambda function called a simple app function. Select the same function and click on save it. So now the Lambda function, it is successfully saved. Now here you can see the status called, it is still in the creating state. So after triggering, after configuring Lambda function trigger in the SQS, so next what we will do is, so we are going to publish messages in the queue. So whenever if you want to publish messages in the queue, so you can do manual publish, or else you can do complete automation also. Okay. So if you want to learn CLI commands, if you want to pass the information through CLI, you can pass the information through CLI. Or if at all, if you want to pass, if you want to send, or if you want to receive messages in the queue, you can also send a message to the queue. Just enter the message here. So that is, you can use a JSON, or you can also put some raw message. And finally, you can click on send a message to the queue, so that the message will be sent to the queue. So the manual process, what I'll do it later. So we'll go for first automation. So after updating, after configuring a Lambda trigger in the SQS queue, next what we will do. So you can take any terminal now. If you want to take Git bash terminal, you can take Git bash terminal. Or in the AWS itself, we have one service called a Cloud Shell here. This is completely cloud terminal. It's like a cloud-based, terminal. So open the Cloud Shell in a new tab. And you can see in the Cloud Shell, by default, AWS CLI and Python and Node.js and some other programming languages and some other software packages will be pre-installed. And here we will have 1 GB of storage in the in each and every region. So per region. So close this, welcome page, and we don't want. So first of all here, if you have already existing message, you can go with the same message. Or else, if you go to my repository, in my repository, you can see there is one more, file called zip file called message body. Open the zip file here. So if you open the zip file, so in the zip file, I have some, messages I kept in the zip file. If at all, if you want to upload this zip file, you can upload this zip file into the Cloud Shell also. Go to the Cloud Shell, go to the actions here. You can see there is an option called upload a file. Click on upload file. Now select your file called message body. This in the message body only, I have some JSON files. Click on open. So now it is uploading a message body into the Cloud Shell, and it is successfully uploaded here. Once it is uploaded, you can do ls. Just do ls here. And here you can see we have a compressed zip file called so we have a compressed zip file called a message body.zip. So we know how to unzip, right? If at all, if you want to unzip, you can use a command called unzip and the message body.zip. Okay. So when you click enter, so each and every message will be unzipped from the a particular zip folder. Yeah. Now after unzipping, so already I unzipped. These are all the messages. Like we have message 1, message 2, message 3, and message 4. So message 5. So if you want to read the messages also, you can read the messages. Use a cat command. So I want to read message body 1.json. Click enter. So here you can see I kept some JSON information, that is product ID, so product name and category and product per unit. So customer ID, customer name, and time of visit, everything. So each and everything I'm going to keep it in the DynamoDB table. So if you want to read all the messages, you can read all the messages. So that is cat body.2.json and click enter. So here you can see I have a different, a product information. Now the product is jacket and, category is clothing. And you can see the customer name is Teja and time of visit is so and so date and time. There's a timestamp. So this is like you can read each and every message body here, but we are not going to read each and every message body. So now whenever if you want to pass, let's say I want to keep all the messages into the SQS queue. If you want to keep messages in the SQS queue, so you can use Amazon SQS, CLI commands. Just go for AWS SQS, a CLI documentation. And go to the SQS documentation here. Click on SQS CLI command line interface reference. And here in the documentation, you can see the complete CLI documentation. So whenever if you want to create a queue, and if you want to publish a message, or if you want to purge a queue, or if you want to send a message to the queue, here you can see there is a separate a method called a send message method. So where we are going to use a synopsis, this is a synopsis, send a message, and we are going to specify the queue URL, and we will specify some message body, and finally that message body, you can put some value here, and that will be sent to the queue. And if you want to see some examples also, you can see some example usage. So this is a complete JSON type of message, and that JSON message now we are keeping in the SQS queue. Let me show you some example commands here. You can see the examples. So AWS SQS and send message. So just specify your SQS queue URL, and this is the queue URL, and after that message body. So you can keep some message body, anything, something like information about anything. It could be anything. And if you want to put some delay seconds, or you can put some delay seconds. And finally, if you can use some attributes also, and you can send it to the destination as well. This is a command. Now the same command I also gave it in the repository also. Go to the README file, and in the README, come down here. You can copy this command and paste it somewhere in the notepad or in the paint. Now here you can see in place of this queue URL, queue URL. Just delete this. Now copy your SQS actual URL. This is our SQS URL. Copy the SQS URL, and after queue URL, paste your SQS URL. SQS queue URL. And finally, I'm going to send each and every message to the SQS queue. Come back to the cloud shell. There is a terminal. Now here you can see when I'm doing ls, now I have all the messages: message 1, message 2, message 3, message 4, and message 5. Now all these 5 messages, I'll send it to the SQS queue here. First of all, use a command called, just paste the command, first command. AWS is a provider, SQS it is a service, and in SQS what we are doing, first we are sending messages. So which URL? This is a SQS URL. And finally, you can see the message body. The message body, it is available in the file 1, that is body -1.json. First, I'm going to send the message 1 to the SQS queue. Click enter. So once the message 1 is delivered, here you can see you will get the message body and you will also get message ID. Next, the same command I will apply, and I'm going to change message 2, message2.json, and click enter. Again, the second message also delivered to the queue. It is sent to the queue. Now go for third message, send third message. And again, the third message also sent to the SQS queue. Now go for fourth message, replace the message body with 4 and click enter. Again, the fourth message also sent to the queue. And finally, let me take the fifth message and click enter. Now here you can see the fifth message also, it is successfully sent to the queue. Once the message is delivered to the queue, now come back to the queues here. And previously there is no message available, right? Just give refresh here. So usually it will take some time. Open your queue. Or else directly, I think if the Lambda is executed, then that message information will be sent to the DynamoDB. So previously, when I'm refreshing or when I'm scanning my table items, there is no item found in the table, right? Now let me run once again. And if I run once again, now here you can see I'm seeing all the tables in the DynamoDB. So now all the tables that is available in the DynamoDB table here. So you can see the table. That is, the first one is the partition key is nothing but simply we can say the product visit key. So this is a product visit key. And next you can see the customer ID here. This is a customer ID. And next you can see the customer name: Teja, Jayashree, Vamshi, and Basavaraju and Pavan Kumar. And you can see the product per unit. And followed by, you can see some other product information. There's a product ID. You can see the product name. There is a packet, kettle, gloves, and mouse, and iPhone, and everything. And finally, you can see the time of visit, each and everything. And even if at all, if you want to download, you can download all the messages, selected items into the into the CSV document. Let me open the CSV document here. Yeah. Now here you can see whatever I have sent some information to the SQS queue, the complete, that information now it is available in the DynamoDB table. So who is sending complete information? So there is a service called a Lambda service. So Lambda, it will always monitor one service called, SQS service. When someone is sending some information to the SQS queue, so that will be sent to the destination called, DynamoDB table. So this is how, the SQS service works. This is a complete, automation. And if you want to do the same activity manually, then you can go to the queue, click on send or receive a message. Just type a message, hello, this is a message 1, and click on send message. Now here you can see the message is successfully sent to the queue. And just go for message 2 also here, and click on send message once again. Again, the message 2 has been sent to the queue and it is ready to receive. And just go for message 3 also. Click on send a message. Again, go for message 4 here. Click on send a message. So now totally how many messages that are available? If you want to give a refresh, you can give a refresh. let me click on poll for messages here. So when I'm polling for the messages, now it will receive all the messages from the queue. So totally I have sent 4 messages to the queue, right? Now here you can see it is still polling. Once the polling is completed, now here you can see total messages that are available called 4. And when the lambda is triggered, again, that message will be, so, sent to the DynamoDB. The destination called DynamoDB table 1. So this is how, the event driven application works. And here you can see, so we have a message ID here, and the message is, this is a send time, and you can see the size here, and you can see total receive count called, 3. Just to come back to the queue, there is a SQS queue. Just give refresh here. Now here you can see 4 messages that are available in a flight. Okay. So when the lambda is triggered, then again each and every a message will be deleted from the queue, because the lambda is successfully processing all the messages from the queue to one more microservice called application 2. And from the application 2, that will be stored in somewhere like database called, something like, DynamoDB table. So this is how, so we are going to keep all the messages in the DynamoDB table. So by using a SQS service. So simply we can say this is one of the simple event-driven application. Okay. Yeah. If you have any questions in the SQS, now you can ask. Any questions online? And if you want any kind of SNS notification also, you can do that. Let's say I want to send a notification to the endpoint, then you can choose one topic. Let's say I want to choose a topic called, in the last class, we created one offer letter topic, or else you can do one thing. You can integrate SQS with the SNS. Open SNS in a new tab. And in the SNS, now let me create one topic. Click on topics here. Create one topic. So just specify the topic name. Go for, standard topic. And topic name is, let's say this is SQS topic. And display name is optional. You can go for SQS, something like that. And click on create topic. So in the last class, we created one subscription called something like HTTP and as well as, SMS program. Now use a subscription called Amazon SQS here. So choose your endpoint call. Just now we created product visit data queue, right? Select the same queue in the SNS topic. And finally, click on create a subscription with the SQS. Once the subscription status is confirmed, now come back to the SQS. There is SQS. I think here is SQS. Okay. So just give refresh here. Let me give a refresh. And now select your SNS topic. So that is, just now we created a topic called, SQS topic, and click on save it here. So now all the notification will be sent to the a topic called, this is a topic, subscription AR. And you can see this is a topic AR. Okay. So now from the SQS, you can send any message to the, one more, a microservice. That means you can decouple the application. And once the message is stored in the destination, sometimes, you will also receive a success message to the destination called SNS. And the endpoint already, we created subscription in the SNS, right? Same endpoint. There is SQS endpoint. And you can see some details about your SQS key here. There is a maximum message size is 256 KB only. So the retention period, you can keep, maximum retention period called 14 days. And if you want to apply, a delivery delay, you can apply a message delivery delay, so that the message sometimes it will be delayed. And if you want to apply, encryption, so it could be anything. And if dead letter queue is enabled, you can also see all undelivered messages or failed messages in the dead letter queue also. And finally, coming to the cleanup process. So first delete your DynamoDB table. Select your table, delete the table. And when you're deleting the table, just type confirm in the field and click on delete it. So don't worry, in the documentation, so I'll be giving the complete, repository URL, and I'll be giving the step-by-step process also, so that just complete, the hands-on activity also. And for code, Lambda code, you can check out my repository. There it will be, there it is available. And don't keep your Lambda function, delete your Lambda function also. And when the Lambda is executed, so you can see all the output information in the log group also. I'll show you that also, just a second. First, let me delete table and dynamo Lambda function. And anyway, SNS topic, you can keep it as it is. So select your queue and delete the queue also. And just type confirm in the field. And in the Cloud Shell, yeah, just do ls. So we have some lot of files. If you don't want to keep all the files, you can remove the files as rm space -rf. Let me remove all files. Yes, when I do ls now, there is no file here. Okay, total files are 0. That's it. So now you can close your Cloud Shell as well. Yeah. And if you want to check the log group here, you can navigate to the CloudWatch. So remember, for each and every Lambda function, we will have a log group. In the log group only, so based on the timestamp, when the Lambda is executed, so if at all, if you are receiving any error messages, or if you want to check all the, it could be any log file here, you can check it in the log group. So go to the log group, and here you can see just now we created one Lambda function called simple app function. Open the simple app function, Lambda log group, and see the log streams here. Now, just now, I think the time is, 7/9. Just go to the latest log stream. 7/9, 99 is 7/9. And you can see, this timestamp. So just now we created, we specified a message called something like hello message 4. So that is sent to the, that is executed by Lambda, and that is sent to the, again, DynamoDB table. And you can check out the previous messages also. This is message 3, and go to the top. This is message 2. Again, go to the top. This is message 2, message 1. You can see the region is, this is a region, and you can check out, that is a data, queue URN is, this is the SQS queue URN. Just scroll down here, and here you can see, just a second. So here we have only the latest messages, that is a message 4 and message 3. So all the messages are successfully sent to the, a DynamoDB table. Okay, and if you want to see the previous messages also, you can see the previous messages. Just come back to the previous log stream in the same log group, and you can check out your previous, log stream also. And this is exactly executed by 6:30, and there you can find all the log stream, all the events in the log stream. And here you can see, so there is a user called Pawan Kumar. So he purchased a product called mouse. So the complete information, product ID, product name, so category, everything. So it is sent to the DynamoDB. Next, one record is created, successfully created. Just go to the previous records. So each and everything. So when the Lambda is executing, so each and every, output or output file, a log file will be stored in the log group only. So when the Lambda is getting failed, then we can check out the log group. Based on the timestamp, we can see where the error, where it is, it is throwing the error. And based on that, we can troubleshoot each and every issues. Anyway, this we will also discuss once again in the, in the Lambda class. Don't worry. This is completely about Lambda. So that's it for, SQS queue. If you have any questions in the SQS queues, you can ask. Remember, most of the times, we will be using SQS queue for Simply we can say when you want to process the message asynchronously, or if you want to decouple the different microservices or applications, so we will be using SQS only. And in the SQS, so you can take some benefit, different advantages or benefits also. One is asynchronous communication is one benefit, and fault tolerance. When someone is asking what exactly SQS, you can say it is a service where we can decouple applications, asynchronously, or else we can establish communication between microservices asynchronously. That is also fine. And using the SQS, we are going to manage all the messages in the SQS queue, and it will use a pull-based notification, a pull-based system where there will be a guaranteed delivery of message at least once to the consumer, that is a receiver. So there are two different types of keys, and these are all the two different types of queues. Then you can explain about the components and how the SQS works. And if at all, if you want to do a hands-on activity for different microservices, so you can create a Lambda function for automation, and somewhere you can store all the log files, that is the product information, and the destination storage device, something like a DynamoDB, or you can take any database, that is up to you. Yeah, okay then. If you have any questions, you can ask, or else we'll just wind up for today's class. And tomorrow we'll talk about SCS service. We'll see how we are sending messages by using SMTP mail server, and how we are receiving messages from the people by using POP3 mail server, and as well as IMAP mail server. So what exactly these mail servers? So using these mail servers, how we are going to send messages and how we can receive messages. So in the SCS, that we will discuss. And once we're done with the integration of application services, then we'll talk about a KMS in the encryption, and finally we'll see the Lambda. Only these three services are left. Okay, maybe this week I'll complete SCS and KMS, and I'll also start Lambda by on Friday. Yeah, any questions? Okay then. Thank you for joining, and see you all in the next class. Yeah, bye bye.